Yeah.
Because like the idea of static is like it's just supposed to not be changed. So it's like similar across all instances of like the same thing. So if you override a static method, then essentially you're changing it. So it's not really a static type anymore. It's not really static.
You're on the right track. Remember, a static method is specific to what? A class, right? Not the instance. Okay, so that's definitely the right train of thought. Roger?
Yeah, I was going to say this. So, there's a single inference of the method that's unique to the class itself.
Yep.
So any subclasses aren't overridden because they don't even have access.
Yeah, okay. So now let me I'll just check this works first. Right, so here's your class, right? Oh man. Sorry, this is a new setup. Here's your class, okay. Right, and we're gonna, this might be like a circle class, or we'll call it a square class because it's a square. And you want to create a bunch of instantiations of squares. These are our instances, our objects. We know that from previous weeks. Man, this pen is not having fun. We'll see how this goes. But when we override a method, right, we make a subclass, it might be like a 3D square or something. How does polymorphism work? In the sense that, this, let's say we've got square and we've got up here. I'm going to give up on this in a second if it doesn't work. I tried. I really did. Okay. We'll go back to the mouse. Yes, here's our square and here's our superclass. And we've overridden some method like area. Right, so area is defined up here and area is defined down here. The runtime polymorphism. So when we say, okay, like, here's our 3D, or okay, so square S equals new 3D square. And remember, we can do this because all 3D squares are squares. I should really call it a cube, I guess, in that case. But you get the idea. We've inherited this class, we've overridden the method. If I want to say square dot do something, right? Maybe square dot get default area or something like that. This is going to pertain to all the instances of the square class. So we can't actually override it because we don't have a specific instance that'll say, no, we're actually going to point to this new defined method area in the subclass, as opposed to the one in the superclass. Does that kind of make sense? Roughly? Because in this one, in the normal, like an instance method, as opposed to a static method, we override it here, and we say, no, even though I'm talking about a square, s.area pertains to this one, not this one, right? That's the runtime polymorphism. Whereas here we're saying, well, no, there's only one square instance, so we can't just go and override this because we're talking about squares as a whole. This could be different to 3D square dot get default area, but that's a whole separate method, right? That lives in the 3D square class. Cool. I think you were all pretty on the right track with that though. So question 2. What's the output of a.f in the following? Yep. Okay, let's walk through that. We make a new C. C.C. Okay. So we're going to use C here, print out right. Cool. Yeah. Okay. Now we cast C to B. Now you don't have to up, I don't think we talked about this last week when we did the equals, but you don't have to upcast in Java, right? You can just say, well, B, in this case, variable called B, so type B, we just assign C to that because C is a subclass of B. Then we say B.speak. Now, what did we just talk about with the runtime polymorphism? Which out of the practice are we going to prove? One. Why? Because we got a original method, right? We had this initial definition of speak, which says, okay, this is what it means to speak, if I'm an object in type B. But then C said, I'm gonna change that to be this definition here. And even though the static type of B is a B, this variable names are crap, by the way. Even though the static type of B is a B, under the hood, we know it's actually a C, right? Because that's the object that we created that we malloc in memory. Okay, so we've got two quacks, and then now we reassign B to be an actual B class, right? So we're not dealing with C anymore. Pretend it doesn't exist. We're dealing with this one here. So what's going to print out? Yeah. Same logic as before. And then C.speak again is going to be the same because has C changed at all? No. Any questions on that one? Cool. And this is the last one. This is more stuff to do with statics and hopefully makes like static methods just kind of more clear generally. We have B1 and B2, they have X and Y, and X is a normal instance variable and Y is static. So we increment X, we increment Y. Now I'm going to say B1.get X and B1.get Y. What's the first one we can print out? So it's going to be one, and one. Okay. So we've incremented X on D1. Yep. That checks out. We X plus, that's specific to variable B, sorry. Do some highlighting instead, a bit more clear. Let's copy this over. That really didn't copy over very well. Can I do this? Okay. So X is 1, and then Y is 1, because we've incremented X and Y. And then we do the second one, sorry, we do B1 to increment X, B2 to increment Y. When we increment Y on B2 and Y on B1, we do the same thing. Yes, because it's static, right? There's only one Y, it lives inside B. It's across all the instances of B. So if we edit that from any code, or we can edit it ourselves, it's private, so we might do that in this case. But you know, if it was public, you could actually go and say B dot increment Y. If it was, oh, but this isn't static. Sorry, ignore what I just said. So we get X, we get Y, we get X and we get Y again. So now, what is the B2 X going to be? 0 or 1? 0, because we haven't actually modified that, right? We've gone to, we said B2 here, increment X, B2 increment Y, but we haven't incremented B2's X. That's an instance variable. It's separate to B1X because they live in different areas of memory. So it's unchanged. Are there any questions on that stuff? Cool. Let me just fix this. I'm using the wrong camera. There we go. Cool. Let's talk about UML diagrams next. So this is helpful for your assignment. And I would go through this process whenever you have to do this thing where you model a domain, you give them some requirements, and you have to figure out what are the entities, what are the actions, what are the attributes. How are we going to turn this piece of code, this is a real world problem. Sorry, how are we going to turn this real world problem into a piece of code that we can use to manipulate and you know, help us solve some sort of problem. So what I want you to do in 1 minute is just identify all the different entities that are present in this sort of block of text. And I want you all to do it standing up because you look like you need some exercise. Some energy boosting. Right. We've got 1 minute. All the entities go. And stand up. All right, time's up. Okay, just from this, what can we just move this? Anyone? Just looking at entity point. What might be your classes in this? Okay. Engine, yep. Producer, yep. Anything else? Unit W. It's a noun. Yeah, so maybe unit W could be entity in the system. This is all high level stuff. What we're going to do is copy all this into a Word document. And we're going to go through this process of highlighting. And you'll do this in lab 3 as well, where we want you to just analyze what's going on and start to segment things into entities, actions, and attributes of entities. So we talked about cars. All right, let's do entities in yellow. And we also talked about engines. Okay. Now notice we've actually got 2 different types of engines. So what could we use here? Starts with I, interface, or the other one is, yeah, inheritance. Doesn't necessarily need to be abstract, but these will be some sort of entity or some sort of class. Okay, so we have this idea of engines as well, and a producer. We talked about that. Engines are produced by a manufacturer. Sorry, yep. Oh, sorry, I didn't unfreeze. There we go. Okay, there are entities. Let's start with that. Now I use Lucidchart because it's really helpful. And what you can do is in Lucidchart, search for UML class diagram. And it'll give you like the components of a UML class diagram that you can use. This is probably the only one you need, and then the rest you can just do yourself with the arrows on Lucidchart. The other thing I like to do is go infinite canvas, which gives you unlimited space. Because one thing that's really annoying is like you make a diagram and then you kind of run out of space for it. Okay, so we've got car to start with. We'll get rid of all this and this. And then we've got engine over here. We've got producer. Let's call it manufacturer. It's used a bit more frequently in the text. And then we've got 2 different types of engines. Okay, thermal and electrical. We're not sure. Maybe this will be an interface. Maybe this will be like a superclass or an abstract class. We'll figure it out. Thermal engine and electrical engine. What else? Okay, let's talk about maybe some of the actions and attributes, and the actions will become methods on our classes, and attributes will be fields in the classes. So the producer is a manufacturing company who has a brand name. Actually, sorry, before we even get to that, the first sentence, this denotes some sort of relationship between cars and engines and producers. So I'm just going to highlight this in green. And we'll talk about what this means in a second. Okay, so producer is a manufacturing company who has a brand name. Okay, that's a piece of data, right? So that might be a field in the class. We'll make that blue. Engines are produced by a manufacturer. Okay, another relationship there. We'll call that, sorry, we'll put the fields in blue and we'll put the actions in green. So this will go blue. Engines produced by a manufacturer, that goes blue. And they also have a speed. Again, another piece of data, make that blue. There are only two types of engines. This is important as well, but we're not exactly sure what it means yet. Let's keep it in the back of our heads. Okay, so thermal engines have a default max speed of 114. Okay, this is a piece of data. Again, a field in the class. Although they can be produced with a different max speed. That one's interesting. That might, the word be produced makes us think of a constructor, like the way you create an object. So let's put this in green because it's sort of method related because the constructor is a method. And the max speed can change. All right, that's a piece of functionality. That'll be a method in our class, probably something like a setter. Another piece of data, default max speed. Let's do that in blue. This is the speed at which they're produced, and the max speed can change to any value that is divisible by 6. So again, we'll have some sort of setter here. Cars are able to drive. Driving is an action. That's a piece of functionality that can be, I guess, acted out by these entities. And then we have this other stuff here. Let's get back to that, and we'll do the rest of the stuff first. So here's our classes. What do we say to begin with? A car has one or more engines and a producer. So we need to make some sort of relationship between car and engine and producer. So we'll start out by saying, well, a field in the car class is going to be engine, which is going to be of type engine. And another field is going to be producer, which is going to be of type manufacturer. And we denote, because we keep all fields as private in the class, you'll always use like the little dash in the top part of your UML box. So the fields go in the top part and then the methods go in the bottom half. And anything that's private gets the little dash and anything that's public gets a plus. And for each of your variables, you'll have the variable name and its type. You don't need to say like what if there's a default value. You can say that if you like, you can say equals something if you want. It's like the notation's not super strict, just needs to be clear. I'll go through like the standard stuff that I use, but it's not like a hard and fast impactful notation exactly. Some of you might have done like database modeling with ER diagrams. It's kind of like that, and you can use whatever notation you're familiar with, as long as it's clear to us. So, where am I? Okay, we've got engines and manufacturers. So let's say, okay, well, a car has an engine. So we're going to make this sort of relationship between these two entities. And now the type of relationship here is important. And the first part of that is a question that you need to consider with every single relationship in the course, and that is aggregation or composition. Does anyone know what either of those two are? And if so, what's the difference? Oh dear, still not having it with this tablet today. Aggregation or composition? Yeah.
I think it's when it's wider than blue. So now it's wider than blue. Yeah.
Yeah.
I'm not sure what I'm doing. Yeah.
You're on the right track with the idea. There's no inheritance involved in this. Sorry, I think I'm just gonna give up on the tablet and go with the old whiteboard markers. So let's say I have a car and an engine. And here's like my floor representation. Now the car doesn't have an engine. No, sorry, the other way around. If the engine is not, if the engine doesn't have a car, does the engine still exist? Yes, right? Like you can have an engine just sitting by itself outside of the car. It's pretty common, cars can change engines. And so the question you need to ask is, if I take this thing out of the container object, right? So the container object in this case is the car, right? Because the car contains the engine. If I remove it, does the thing that I'm removing cease to exist conceptually? And I'll give you another example. What's a good example? Breakout rooms, right? So you have a call, right? So let's say I had another entity here called, online call. And within an online call, you can have a series of breakout rooms. So something like, breakout rooms will be a list of rooms. And this is a room. Now, if I rip the room out of the call, right, or the call dies, do the rooms still exist? No. I mean, you could argue in some cases, yes, they do, blah, blah, blah. But sort of, at least at conceptual level, you're like, the call can only exist, the breakout rooms can only exist if the call exists. So that is composition. Composition says if I take the engine out of the car and then the engine can no longer sort of conceptually exist, then it's a composition. So not related to inheritance as such, because there's no extending or superclasses involved. It's just a relationship between two entities, two classes. And you say, well, what's the level of dependence at a conceptual sort of, as a concept. So in this case, we have an aggregation here where I think a car can actually have multiple engines. So we're going to make it a list of engines. And I'm going to put the diamond on this side, and it's going to be a blank diamond. This says there's an aggregation relationship between car and engine. Now, for car and manufacturer, if a car doesn't have a manufacturer, can it still exist? Not really. There's a lot of like gray area with these sorts of things, and you could argue both ways and stuff. But like any kind of questions we give you or like problems will be kind of clear cut as to one or the other. So in this case, we have a composition here. Oh man, sorry, I'm going to do this again. And it's a filled in diamond. Any questions with that so far? That's the first part. The next part is what we call the cardinality, which says, well, okay, maybe there's some sort of relationship between car and engine or car and manufacturer and, it's aggregation or composition. But what we also care about is how many, right? And we talked about this thing here. Well, actually, a car can have multiple engines. So we need a way to denote that in our diagram. And we do that by saying, well, one car, and I'm going to drag it over to the car side, can have 0 up to infinite. The star means infinite. One car can have 0 to many engines. Sorry, from 0 up to many engines. So this is what we call a one-to-many relationship. You don't have to worry about it too much. There's like lots of stuff in database design to do with like many relationships and junction tables and resolving stuff. We don't really have to worry about it because we get a bit more flexibility in Java with generics and lists and stuff. But essentially, if you have a list of engines, one car has many engines. What about this one, car and manufacturer? What would be the cardinality here? Yep, so. So think about like the semantics. So if it's many to many, a car has many manufacturers and a manufacturer could have many cars. Many to one or one to many, depending on which side you put the entities, right? So car only has one manufacturer, but a manufacturer produces lots of cars. So one manufacturer can produce many cars. Now the other one here is there's a relationship between manufacturer and engine, which is probably the same thing, right, as what it is for the car. So there's a composition, and one manufacturer can produce lots of engines. Any questions about that? So the next stuff is how do we do inheritance and class modeling in terms of methods. So we've got this engine here, and we've got thermal and electrical engine, and there's going to be an inheritance relationship, right? Now, if we go back to our problem, there are only two types of engines. What does that imply? That an engine. Yeah, exactly. If you get an engine, it's either going to be a thermal or an electrical engine. Now, there's stuff that they have in common, right? They have this idea of max speed, that's kind of it in this case, but there's going to be some commonality. So, you know, maybe we'll change this later when we actually get to implementing it, but probably for now, the guess is that it's going to be an abstract class. So what we do here is we make this italicized that says the class is abstract, and then we put in arrows to denote an inheritance relationship. And we generally make them the empty arrows. They point up. Now, what actually is going to go in the class? And this is interesting because we start to think about how we abstract variables. And I think some people in the forum, they always, every term they always ask, oh, how do we do like abstract fields, right? You want to have a field that's, you know, common to all classes, but then is different in each class, which is kind of like what we have here with this default max speed. So there's a bunch of ways you can do it, but the way we're going to do it here is say, well, okay, there's this idea of a max speed, which I think is just the same as the normal speed, actually. So there's the default max speed, and then there's the actual max speed. That's common to both. So we're going to put it in the superclass. It's going to be a private field, max speed, which is going to be an int. And then what we'll have is a setter, which is just a method. And again, we've got this plus for public set max speed, which is going to take in an int. Not going to return anything, so we'll just leave it like that. We probably also need a constructor, engine max speed, or actually, sorry, engine, which is going to take it in int. You could name these if you wanted to. You could like write it almost like a, you know, a declaration like you would in the actual code itself. It's pretty flexible. So long as you show the type, this is fine. And obviously the name of the method. Okay. And now each of these will have a default max speed. So let's put these in the class, default max speed. And these are probably going to be static. So we underline them. And same thing here. And you can say, we can even say what it is because we know what it is equals, was it 114 and 180. Cool. Blah, blah, blah. Now, so there's stuff around changing the max speed, right? Which is, again, common to both classes, but it's different in the sense that the idea, the abstraction is common, but the implementation, how it actually works is different. So what we're going to do is make an abstract method. And same as with the class, we italicize the method name, say, oh, we've already done it here, right? So we just put this in italics, and then in the concrete classes, we actually have to go and implement it. Right, that's how abstract classes work. And so we do the same thing here. And these will be two different definitions. Cool. I think that's all done. Now cars are able to drive to a particular location X, Y, right? Let's do that. Public drive, int. Okay. Now, let's look at this bit. Since blah, 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 they want you to be able to model the behavior of time traveling for any vehicle and to model a time traveling car, a vehicle that stays in the same location. Sorry. Oh, a vehicle that travels in time stays in the same location, but travels to a local date time. All right. What might we do here? So we have this idea of time traveling, and we also want this time traveling car, but we want to be able to say, well, maybe we can make a time traveling plane tomorrow. Where does that make a subclass? We'll call it time traveling car. Get rid of all this because it's in the superclass. And then inheritance. Cool. What about we want to model the behavior of time traveling for any vehicle? Any idea what we could use here? Another inheritance sort of base structure that we haven't used anywhere else in the problem yet. Yeah, interfaces. Anything else? Extra class, we use that. Let's run an interface. And whenever you see the idea of modeling a behavior, think of the interfaces, because what interfaces allow you to do is, right, like you can implement as many interfaces as you want. You can say public class B, extends wondrous or whatever we have here, but then I can implement, so we can only extend one thing. We can implement, A, B, C, D, E, whatever, as many interfaces as we like, which means that you can treat this as an A, you can treat this as a B. I think some of you, we talked about this last week in the lab, where we can make these abstractions. What we want to be able to do is make a time traveling abstraction. So what I'm going to say is, well, this thing, this vehicle, this entity is time traveling. And we know that the time traveling car implements this interface, which means that the method time travel, which will be to X, Y, Z, we know that that method will be implemented in this class. That's really useful because we can get some guarantees, right? We can actually do like a typecast and say, well, I can cast this to a time traveling variable and I can call the time travel method on it. Really useful. We'll see a lot, particularly when we get design patterns. Sorry, I put this in the wrong spot. With interfaces, you use the angle brackets to say this is an interface. And a pointy, non-filled out arrow with a dotted line that says I'm implementing this interface. That's pretty much everything you need to know about UML diagrams. Use this as much as you need to for your assignment. You'll need to do UML for that. You'll get given a UML for assignment 2, but you'll need to extend it and change it. And we'll probably give you like a lucid chart link as well. So I mean, I would recommend using lucid chart, but you can use it for yeah, any questions?
So we don't have this. This so every time
Yeah.
They're produced at the same thing as the so with that, basically this result from the cost another response
Yeah, like so neither we haven't put the structure in subclasses, but I think we probably should have for the thermal the thermal engine. Yeah, but for the thermal one, you can produce it at a different max speed. So for this one, what we should probably say is plus thermal engine int, and then for this one, have a constructor with no arguments, because as you said, it's going to just be produced as a default. Okay. Yeah, because remember how in the subclass, you just always need to override the constructor. You always need to make it the constructor. You put it in your UML as well. That's because it's an abstract method. If you mark a method as abstract, saying I'm not going to implement this in the abstract class, but I'm going to make the concrete class, so I'm going to do it. And you put it italicized, just like the title in the abstract class, and then normal is the concrete class.
So yeah, so then time it takes some creating. But in their price, it's saying that it stays in the same location. So the different type of
Sorry, I should change this. It's probably like this.
Yeah.
Instead. Yeah. There we go. Oops. Good pickup. Any other questions?
Yeah, you said you saw it.
Sure. Do you want, I can get any link with, and you can just point it and. I hope that was useful. Let's get on with the rest of today's content. Got 10 minutes. Okay. I'm going to talk briefly about using VS Code, and we're going to look at this wondrous problem. But it's mainly about, we're not going to get to this exception stuff, but we're going to talk about how to use VS Code to debug, which is going to be super, super helpful. And like most of you at this point probably still debug with print statements. Put your hand up if you still do that. That's completely okay, because no one's taught you how to use an IDE yet, which is what we're doing today. So we have this wondrous sequence, which is a simple rule. If the current term is even, then the next term is half of the current term. If it's odd, then the next term is 3 times the current term plus 1. So blah, 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 you know, here's the sequence. If the starting term is 1 and then empty list is returned. So we have an implementation, we have a test, and the test fails. Let's have a look at this. Here's our wondrous. We'll get rid of this crap here. And here's our test. So I'm gonna run the test. Cool, test fails. All right, so assertion failed error. Now, when you're debugging generally, and like this is just sort of general, I don't know how to put it, like approaching problems, right? Like you're like, I have a problem in my code. I get this all the time. You go, I have a problem in my code. And I say, okay, well, have you identified what the problem is? Like, oh yeah, this isn't working, blah, blah, blah. The first thing you do always is write a failing unit test. Because then you now just don't have, you know, here's this abstract bug that we can't quite conceptualize. You have a test that you can fail, and you know that if you pass the test, what does that mean? It's not there. Yeah, like you fix the bug, right? So in this case, we've got 3, 10, 5, blah, blah, blah. It was 3, 10, 5, 16, 8, 4, 2. Okay, what's the difference between the expected output and the actual output? Missing. Yeah, missing 1, right? Okay. Look at the code, you know, we could probably solve it just by looking at it, but what we're going to do is put a breakpoint on line 13 and run the test in debug mode. I don't know why it says line 14. And I'm going to say, go back to the test and hit debug test. And what it's going to do is it's actually going to stop the whole program mid-test and say, I'm going to pause it here. I've paused execution. If you hit play, it'll keep going. But what we can see is it gives us all the variables that are currently in play. So I can see that start is 3, current is 3, the sequence is, I'm going to make this bigger, an array list size is 0. Okay, and then we also get all of the class scoped variables as well, like this one. Super useful. If you want to, you can add like an expression into watch, which says, you know, maybe it's like this isn't going to change or anything. My magic number divided by 6 or something. And then it'll continually reevaluate that and tell us what's going on. And you also get this thing here. Does anyone know what this is? Sorry, it's giving it away. It's a call stack, right? Which says, where are you sitting inside this chain of methods? This is really helpful for OO because, and you might have started to notice this, is that you'll get a method that calls a method that calls a method that calls a method that, you know, does this whole thing, right? And you you know, like what we've done here, a lot of this stuff is, you know, like what even is this, you know, part of the execution of a Java program itself. But once you get through up until our test, you see, well, here's test basic, which is called Wondrous. Again, particularly useful when you've got bigger code bases and you start to work with, you know, methods, calling methods. So you can trace through and kind of see what's happening and do a bit of detective work. So anyway, that's the parts of the debugger. What we really want to do is say, well, we want to know why one isn't getting added to the return list, right? So what I'm going to do is going to hit this play button, which says, am I going to do that? No, actually, I'm going to hit this step over button, which says go to the next line of code. And current is not equal to 1. So we go, okay, next line. We add this to the sequence and you can see that updates. Current mod 2 is not going to be equal to 0. So we're going to go to the second rule. Okay, that seems fine. Sequence.add, that seems fine. We'll keep doing that for a bit. And I'm just going to hit play, which is going to take us back to the next breakpoint, so that we skip over it a bit more. Okay, so these are getting populated like they should be. We get to 5, 8, 4, 2. Okay, now here's where things get interesting. So we'll step over again. You can see that it returns a sequence and doesn't go to 1. Right, like it went 2 and then current not equals 1. Then I think, sorry, I lost train of where I was. But then current was 1. But we didn't actually add current to the list. So what's the problem? What do we need to do? Yep. We could add 1 or you could add current because, like, you know that by virtue of this loop finishing, current will be 1, but let's add current just because it looks a bit nicer. Cool. And that'll finish. The test will fail because we didn't rerun it. Now let's run it again. And I'm just going to take the breakpoint out and hit play again. And woohoo, the test passes. Happy days. Cool, that's good. The bad news is there's another bug that we didn't actually catch. The test didn't catch it. So we need to find the other bug and write a corresponding unit test. Now, there's lots of ways you can find bugs, but let's just assume that, let's just kind of look at the code and think, well, this all kind of looks okay. We kind of verified that, but have we covered all of the edge cases? And is there anything in the spec that you think the code might have missed? Anyone? Yeah, that sounds all right. I don't know if we've accounted for this rule. Right, like there's no if statement here or anything like that. So before we actually go and fix it, we're going to do what I said at the start. We're going to write a failing unit test. And we know that once that test passes, we will fix the bug. So I'm going to say public void test1. And this is how we write JUnit tests. You just write another function. We decorate with this marker at test, which tells the VS Code, hey, you can run this thing. We'll copy most of this stuff. Except, what do we say? If the starting term is 1, then an empty list is returned. So we're just going to initialize an empty array list. I'm then going to say assert equals expected w.wondrous with 1. Assert equals is just like a function. It's like assert in Python or JavaScript or whatever you've done before. There's lots of different assertion functions that you can use. You can look them up. It's very well documented and not too hard to figure out. So now let's run this test. And you see the test fails. Okay, cool. We probably don't need to go through the whole debugger process again, but if you wanted to, you know, you stick in a breakpoint, run debug test. Sorry, I've run the wrong one. Run debug test. And, you know, you can go through this whole thing of, you know, looking at the variables and seeing what's going on. We kind of know what the problem is. What should we do here? Sorry, at the back, did you have something? Yeah. Now let's run both again. Check that it works. And take this out. Cool, and they both pass. That's how you do test with JUnit. That's how you do debugging. Oh, bang on 7 o'clock. Let's very quickly just talk about exceptions. All I want to say is that if you want to denote a method as throwing an exception, what I can say is throws illegal argument exception. And then you might have something here that just does some verification for some, yeah, that just says, you know, if start is less than 1, throw new illegal argument exception. Sorry, wrong one. And then you could also give it a message if you wanted to, like saying hello. Now, often you will have to test for this, like, you know, like any other behavior exceptions or things that you want to unit test to make sure work correctly. Sometimes you will need to wrap function calls with exceptions inside a try catch. Does anyone know why that is? Like if I say, if this threw an IO exception for whatever reason, I'll just change that. I got a wondrous test. It says, no, now you have to handle this exception. And this is a software safety thing. It says, well, you know, and like you might be using Python where it doesn't matter, but in a strongly typed language like Java that says, no, if you're going to raise an exception, then we've got to do something about it, right? I don't want you just sort of bug out and spit the dummy. So often we can do this thing where we surround it with a try catch and say, well, try do this. And then if it throws the exception that you said you might throw in the declaration, then we'll run this other piece of code to, you know, clean up the mess. We don't actually have to do that in the case of what the question is asking us to, because this is what we call an unchecked. Sorry, I've gone too far. One. Yep. This is what we call an unchecked exception. It says no. It says, well, it doesn't matter. Like maybe this will get thrown, maybe it won't. You don't have to handle it. Whereas the IO exception that we just changed to is a check exception says no, if this is going to happen, you have to try, catch, handle things together. Any questions? No? Cool. Thanks very much. I'll see you all in the lab. We talk about lab stuff, talk about assignment stuff. Any questions you have?